So continuing with our journey to identify semantic relationships, relations, and similarities, we can continue using Wordnet through NLTK. And here I've assigned different synsets or definitions to variables here. So I'm looking at first gloss for tree, and a lion is a noun, a tiger is a noun, a cat, and a dog. So I'm reading these in to their variables, binding them. And what I'd like to do is to take a look at these entities, and I want to see the relationships between them. And so for this code, lion is not defined. Let's go back and run this. There we go. So first of all, I'm just printing their definitions to make sure that the definitions I've chosen match the synsets. And I'm looking through, and tall woody plant, large gregarious feline in Africa sounds like a lion, feline in forest in most of Asia, it's an Asian tiger then, and this is a definition for a cat, domestic cats, and dog, canine, so that looks right. So then I can look for the hypernyms. Remember, these are the terms above the words we're looking at to see where there are commonalities and where we can find word similarities between the words. And I'm using pandas again, and if I look for the hypernyms, we can see a tree, and tree is a tree. But if we compare tree and lion, we go up the tree, the first commonality is that they're both organisms. And same with a tiger in a tree, cat in a tree, dog in a tree. If we compare lion and lion is the same. But just like lion and tree here, we have tree and lion as an organism. But it changes then when we compare tiger and lion, we see they're both big cats. So that will give us some information about the relationship between these two words. A lion and a cat, however, are just both feline, meaning cats, because a cat is a lot smaller than a lion, so they're not both big cats. Lion and dogs, however, are both carnivores. They eat meat. So you can see we can find relations between lexical items through the hypernyms. So this leads us to word sense disambiguation. When we have a string, we need to identify the meaning in that string, and we need to know what the words are. So that string gives us the context. And so in this last two cells here, next two cells, we're looking at word sense disambiguation using the Lesk algorithm. And the Lesk algorithm takes words in context and looks through their dictionary definitions, and it finds the definitions in each of the words and finding the ones that are most similar, and then it chooses the sense for that word based on the words in the local context around the word. So let's take a look at this and look at the code. So we have two samples here, and it's a list of two words, and I was looking for the noun in both. So I want to see fruit as a noun and fruit as a noun. And here I'm looking up the word fruit in these two. And so this, using the sentence and the part of speech for each sample, it tokenizes and puts everything in lowercase, and then it looks at the word and part of speech, gives us the sentence and the synset, and then the definition. So the fruits on that plant have ripened. So we see that this fruit, even though I'm calling both of them as nouns, it has shown me different synsets for each based on the words surrounding it. So in this first one, the fruit is an actual fruit that we eat. And then the second one, he finally reaped the fruit of his hard work. So this is more metaphorical. It's not a fruit that we eat, and you see the consequences of some effort. So this Lesk algorithm was able to disambiguate the word fruit in each sentence correctly. Let's take a look at another example. We have three sentences here, and looking at the word lead or led. If we have that word just by itself out of context, it's difficult to identify its meaning. And so I'm looking at LEAD in this first sentence. Lead is a very soft, malleable metal, and you may be wondering why I'm putting the part of speech here. This is just to run the code to see if it works. Remember that you can run part of speech on a string after it's been tokenized, and so you could feed in this word with the part of speech that's been tagged and get the same effect. But in this case, we're going through each sentence. John is the actor who plays the lead in that movie, so we have led in the first sentence, lead in the second. They're both nouns, and the third is the road leads to nowhere. So lead and lead are the similar pronunciation, but the part of speech is different. So we're looking for this word in all three sentences, looking at the sentence and the part of speech tag in these samples, and then printing the results. Let's see what we get. So this is our sentence, and this is the synset it has identified, and it's a metallic element, bluish white, so that looks like it is a metal, so that's correct. The second one, lead in the movie, and this is identifying it as the star, the actor who plays the principal role, so that is correct. And this road leads to nowhere, so the run causing something to pass or lead somewhere. So this is metaphorical, it leads to nowhere, and it's also directional. So it looks like it's doing an okay job of disambiguating this word lead or led in all three sentences. You can try your own, change the sentences and change the word and see how well it identifies or disambiguates the words. If you'd like to read more about the LESC algorithm, you can click on this link, which will show you some of the code in NLTK, how to write it. And then also I've put this cell down here for you to try out your own sentences. These are tokenized, and you can use this, print the LESC algorithm here. So sentence 1, I went to the bank to deposit money, so I want to look at bank as a noun, and you can feed this in, and you see you get the same result here. And if you want to see what the definition is, you can put this result into this code here and check the definition to make sure that it is the meaning that you intended.